Hello, everyone. Welcome to my talk. I will be standing here and not here, so you won't think that there is a wooden stand talking to you, which means I use clicker, which fucks up sometimes, so I apologize about that in advance. Okay, so a word about myself. I'm very excited to be here today and to share my research, and it's already started. So I'm Vera, a vulnerability researcher at Clarity, Team 82, which is vulnerability team. What we do in our day-to-day, we look for vulnerabilities in XIoT devices, OT devices, and we disclose them responsibly to the vendor so they can patch it, and our customers won't be vulnerable anymore. And then we present our research like I'm doing here. And from time to time, we do participate in hacking competitions like Ponton. It's not working. Like this one. I will stand like right here. So these are pictures from last month. We won a Master of Pon from Ponton, Miami, which was quite cool. So let's start talking about the intercoms. So this research started quite by chance. Our company moved to a new building and new offices, and when we came, something new and shiny waited for us. It was a smart intercom. You're probably familiar with something that looked like this. It was Aquavox E11 smart intercom. Or door phone. It was plugged to the Ethernet and powered by it. It has an NFC sensor, so the workers can, employees can use their work card to enter the offices. And in addition, some more exciting features. It has a sleep server, so someone from the residence could call someone at the door and see and talk to them, which is nice. And to do that, the intercom should be equipped with video camera and microphone. And another feature that it all was connected to the cloud, so remote administrator could configure the device and manage it. So first things first, we need to solve some problems for ourselves as researchers of some sort. It turns out that our room was the closest one to the door, to the entrance door, and that's how our first month went on. We just jumped off a chair every 10 or 15 minutes to open the door for someone that was locked and forgot his card. And it was annoying, especially for me, as I was the closest one to the door at the room. And I need to solve it, and I figured out that if it is smart intercom, it has some API to it, so I can open a door without coming off my chair. And fortunately for me, I didn't have to dig too deep. It was right there in the documentation. We have our simple API. It has an IP of the intercom. I need to be connected to the same network. There is an action to open door and some simple authentication mechanism. So I needed a way so the employees themselves could use it. The fastest and securest way was to just implement it within a Slack bot, and that way an employee could come to the office every morning, tap on the floor he want to enter, and just use this API, and the door would be open. That's nice. I can forget about the healthy habit of coming up and go back to my disassembler. And that sparked my interest because I saw an API, I saw some actions that can be done from a remote location, and we saw some authentication mechanism. And the question is, what else can be done, and are all those actions are properly protected? And that is when I decided that it is going to be my next target for research. And this is when I need to decide with myself what is the end game for this research would be. And there are some trivial methods. I'm sorry, I need to listen. I hope you're reading it right now. So open remotely video and microphone and open the door remotely from the intercom I do not own. It would be nice. And since the intercom itself is a small computer, we would, like any good hacker, want to run a code on it. So let's start with it. IT do not like when we break their devices, and they didn't let us to use the one that at the door of the main entrance. So we bought one for ourselves. And that's how we would look like for 4 weeks or so. And to not get too bored, I decided to start the research without the physical device to see what can be done. And luckily for me, the firmware was online at the Echovox website, which happens quite often for IoT devices, and it was unencrypted, which saved me a lot of headache and time. So this is where we can start our journey, and the first thing to do would be to emulate the firmware, as we do not have a physical device. And the thing that we would like to start to emulate would be the web server. This is the main interface with which an administrator would work to configure the device and manage it. You can think it as the same interface you use in your home router to set up a password or something like that. And as I said, the firmware was unencrypted, so we can use Binwalk to just extract the files. And I was happy to see that it's regular Linux-like operating system, which is very good for us, because those binaries will be very easy to emulate. The next thing to do is to find the web server. Binaries, the implementation. A good place to look for is the init procedure. The web server starts up at the boot, so it has to be in some init file, and indeed it was in init.sh file. We see here the latest web server and its configuration, so we can find all the binaries and the implementation. It was compiled C++ web server that was served by fast CGI. So the next thing to do for us is to run the web server, and like many IoT devices, this one as well is an ARM-based device, and we need a ARM-based host to run the binaries on it. And we had some Raspberry Pi around, the lucky ones. And that's what we did. Also, we used a root command to make the firmware file system to be the root file system. It would help us with dynamic linking when the binaries are run, and it will prevent us from messing with the entire file system by mistake. So that's what we did. We see here that we use the root to the main system, and then we use the same command that we saw earlier at the init script. And the server is up. Great. We can start to explore attack vectors, local attack vectors currently. And the first thing for us to do is to find the implementation. So it's all compiled binaries, as I said, and there is a lot of binaries, a lot of code. We don't want to reverse engineer everything. We want to reverse engineer the smallest part as possible. So we have our IDA and the binaries on one screen and the user interface on the other. And what we do is to find the correlations between the two. It was not long until we have found it. And the goal will be here is to first get authentication bypass, so we can use much broader attack surface, and then we would like to run code on it. or run code without authentication. That could be also cool. So what we did was go over all the functionalities in the hope to find one that does not require authentication, and hopefully it would lead us to the authentication bypass. And we have found one. This is a functionality of extract configuration of the device. In the UI itself, it sure does require authentication because the web interface is guarded by username and password, but the API itself does not check for any session cookies, so any HTTP client can trigger the request, and that's how we download our configuration. There were a lot of files within that configuration, and one is specifically interesting. This is an INI file with all passwords and for many interesting services that the Intercom uses, but no authentication bypass yet. The passwords are encrypted, and the next question that we need to ask ourselves whether it's properly encrypted. And I hope that you know the answer to that one. Otherwise, this slide wouldn't exist here. So this was a pretty badly encrypted, okay? You see that it is hard-coded password forwarded to a decryption mechanism. We know the algorithm, we can use the password, and we can now decrypt the password. It is the admin as expected. It's a default password in our new childhood environment. So web authentication bypass is nice, but if we are in local network, we already have a pretty powerful possibility as it is without the intercom. The question is how many intercoms are publicly available so they can expose to the internet. And for those who are not familiar with Census or Shodan, this is a service that shows how many hosts are publicly available by some query. I'm sure that it's not the best query that I came up with, but we see here around 5,000 open devices. That means for 5,000 open devices, we have a web interface bypass. We can download the configuration, decrypt the password, and enter the web interface, and to do whatever the manager would able to do, which is open doors, look at picture, call logs, etc. So that's cool. Let's run some code on it, shall we? If it works. So we are talking about RC vulnerability in web interface and in embedded devices, IoT devices, and web interface in general. The best way and the easiest way will be command injection vulnerability. Those are very easy to identify if they exist and very easy to exploit. So it didn't take too long to find one. We see here some variable is passed and propagated to the command, and then is executed with system function. So let's see the command that is executed is just busybox move from some, I guess, picture, as we see by the extension, from one location to another. And since those file name is, there is no sanitation here, we can look at this like this one. Okay, so what we need to do is just to take our shell command and decode it as a file name, and that's it. One small limitation, we cannot use spaces and backslashes, but since it's a Linux device and we have a bash deployed as a shell, it is not that problem. So this is an example command that we would like to execute. We do not have some interactive shell, so we need to redirect the output to somewhere else so we can download it later. We will execute an ID command which will show us the user ID and group ID of the system. This is what it will look like to not use the spaces and the backslashes. And another annoying somewhat part that the file must exist. It's a little bit annoying because now we need to find a functionality that will enable us to upload the file, which is a pretty strange name, right? Luckily for us, we found one. It is burp snapshot from a request. We see here the file name. This is our picture, and this is the name of the file. It's pretty strange. We would hope that the server would sanitize it and won't save it on the disk, but this worked for us, fortunately. And now we can trigger our the common injection vulnerability, which is the function that we saw earlier. This is the path, which is redacted, and this is our command. And now we can chain it all together to see if it works. I hope that the emoji talks for itself. It works. We download the configuration, decrypted the password, uploaded the file, downloaded the result, and we have our root within it. So this is for a first RC, and for the second we have no time, unfortunately, but it is documented in blogs, so you should read it. Pretty cool as well. And it was the times that we could explore the remote attacks vector. For now, it was only the local one. We need to be within the same network or talk to only publicly exposed devices. And right now, we will talk about all the devices that only connected to the cloud, for example. And fortunately for us, the Aquavox device did arrive. This is mine. It's not what came in the package. And we could start to explore it. So right now we have our legit Aquavox device. We can get from support password to the mobile interface, and here we see mobile application that uses many straightforward functionalities. We can open a door. There is a web API that implements it. We can call the intercom to see who is at the door, and we can open the camera just to see what's happening outside our premises. And another cool feature would be the door log. Each time a door is open, a picture is taken and uploaded to the cloud, so we can download it later. And I wondered how it happened. Oh, it was spoiler alert. So you already saw. It is interesting to know how the images gather, and are they securely uploaded and downloaded, and you know the answer already. So this is an FTP plain text protocol which exists for quite some time. We see here the communication with login to the FTP server and upload of the picture that was taken when the door was open. So there is a couple of things to note outside that it is not an encrypted protocol. We see that Aquavox user, that means that it's the same user for all intercoms in the world, because there is no identification for the intercom, which means the same password. And it is bad enough. Oh, I'm sorry. Yeah, that's what I talked about. It's all uploaded to the root directory. All pictures from all intercoms in the world to the same directory, and moreover, it has a MAC address embedded within the picture, so we can identify the device. And it wouldn't be so bad if we couldn't list the directory. because we would need to guess the name of the file to download it, and that is the answer to the question. We asked to list the directory, and we got the answer with content. And if one picture worth 1,000 words, what about 1,000 pictures? So this is, the joke is on us because we had this intercom in our building, and my picture and my colleagues' pictures are all in the root directory of that FTP server. It was pretty annoying and sad. The listing functionality is not working today, which is good, I would say. So we will move to the SIP protocol. So with FTP, we didn't have an actual power to do something by ourselves. It was some passive attacks. We could see other pictures. We could identify the intercoms where it came from. But now we would like to know whether it is possible to activate the camera and the microphone on demand on the intercom we do not know. We do not own, and the good place to look for this type of vulnerabilities will be a SIP protocol. A word about this one. So this is a protocol for video and audio communication. We have 2 parties or more, and the SIP server who is responsible for access control, who can call who, and this is how it looks like. A user will call the intercom, and we have here is the SIP stream along with RTP stream. This is okay. The administrator owns the intercom. It is possible for him to communicate with it, nothing wrong. And the question arises here. What will happen if I own my intercom and I will call another intercom? The thing is that when a call is received by intercom, by Aquavox intercom, the microphone and the camera are opened, just without any clicks or something, just forced to be open. And this test was very easy for me to find out because we have our intercom that is within our lab, and we have another one that is outside of door entrance. So I called from my SIP, the Aqua that I ordered from my SIP number to one that at the door, and went out to see if the camera was activated, and we see that it is. What it means that if someone owns some devices, and if, for example, this has nothing to do with cryptography, I'm sorry for the names, and if on some devices, she can just call another device and force the camera and microphone to be open without Bob being able to do anything about it. That's pretty crazy. So this is where we decide to stop this research and not to poke the web API, and without knowing that the hardest part of this research is ahead of us. So this is sad. This is a sad story. Aquavox is a Chinese company. It has a quite large number of white label company and resellers. And what we did was to find a way to disclose those vulnerabilities. They didn't have any, but we found some support email and sent a ticket to it, sent a email, and the ticket was opened, and the day after it was closed, maybe by mistake, we don't know. So we opened another one, it was closed another time, and this one, they blocked our account, so we cannot open tickets anymore. We did say that we do not want any bounty, we just want to disclose vulnerabilities, but it didn't matter to them. we reported this vulnerability to Coordination Center, CERT, and they tried to contact the manufacturer as well without any effect. And for a month we tried back and forth. Maybe something would change, or maybe they would update its firmware, but it didn't happen. And we transferred our report to ICS-CERT, and yesterday the CVEs were published, and as well as the advisory. So this is a publication from yesterday from ICS-CERT and some media. This is our blog that you should check out. There is a lot of vulnerabilities that I didn't talk about because we didn't have a time. This is all the CVEs that we did talk about the most severe ones, but still some mitigations. So if you go to the website and see the firmware, you will see that it's still the same firmware. It was a year and a half ago, and nothing is patched. Aside from FTP, that listing is not working, at least not for Aquox user, which is good. But to prevent ourselves from attackers, we can do some things, and we should do them. If you have some intercom, you should check whether it's publicly accessible, and if you manage this within local network, you should use the segmentation and isolate it from other parties, and change the default password of the web interface, which it won't do anything because of the vulnerabilities, but whatever. And thank you, that's all.
Questions? Thank you very much about all the vulnerabilities that you discovered. There are a lot. And I wanted to ask you how often you find that you report to vendors and you get the same amount of the same response. Like, and what people can do actually with that, because they have it installed.
Yeah. So that's a good question, and there is a lot of morality issues that every vulnerability researcher, white hat vulnerability researcher, had to deal with it. Because we do publish to the public, and as you saw, none of the routers were visible. All the passwords were hidden, so no script kiddies can use this presentation and do actually damage. Today, it's not happens very often, actually. With Chinese companies, maybe it happens more than with others. But we are often do get responses, and sometimes those vendors that we send vulnerabilities to them, they become our partners of Clarity, and it gets better. It gets better because of this type of things, because it goes viral, and there is a lot of pressure on the companies like that. And I hope that now when it's public, maybe they will make some procedure to report the vulnerabilities.
Thank you. So you find it actually very good that you publish things online and then it improves the security. It gives another incentive for the vendor to fix those things because they're losing clients.
There is advantages and disadvantages, of course.
Hi. Thank you for the presentation. Very interesting stuff. I noticed on SIP there was authentication. What credentials were you using for that? Is it
so it's a nice catch. The thing here was Bob and Eve. They both had valid Aquox devices. It wasn't an attacker without a device. I need to be logged into SIP server to be able to call another device. So it's the same thing as we saw with macOS earlier. The attacker just would buy a device to be able to do that. So I'm buying the device. I have a valid SIP number, and I can connect to the SIP server. And what the SIP server should do is to manage the calls in ways that I won't be able to make a call to the other intercom. I would just want I should be able to get the permissions to do that. But so that's a problem.
Thank you.
No other questions? Excellent. Thank you very much.
Thank you.